How you doing today? My name is Tom Sukup from Patriot Pool Heating Company. I am the owner and designer. I have 25 years experience in the mechanical and HVAC trades. In this video, we're going to talk about our approach of how we heat pools. One thing I'd like to discuss right now is the math and the science and really truly the fundamentals behind heating a body of water. And specifically here, we're going to talk about pool heating. And we're going to be very broad about it and very generalized. We're going to be in a perfect world that the water temperature, the air temperature is 2 degrees above the water temperature. There's no evaporation here. But I just want to go over the general, the mathematics behind it. One of the phrases I tend to use very, very often is that figures don't lie and liars go figure. I have had times where I pulled the figures up and I'm going, this just doesn't look right. But when I've implemented those figures and put them into practice, they're spot on. The math has been around for a long time. It's physics, it is known, it has been used, and it's very important. The mother formula behind all of this is something that's been around for the ages. The formula is that it takes 1 BTU to heat 1 pound of water in 1 hour. But you say in pounds of water, we deal with gallons. Absolutely. So you take 1 gallon of water, which is 8.33 pounds, round it off. So it takes 8.33 BTUs to take 1 gallon of water to raise it 1 degree in 1 hour. So let's put that into practice. 1 gallon of water is no different than buying a gallon of milk in your local store. Pools are much bigger. So if you take a 100,000 gallon pool and it weighs with 8.33 pounds per gallon, it weighs 833,000 pounds. So it's going to take 833,000 BTUs to raise that 100,000 gallon pool 1 degree in 1 hour. Say you have a pool that's at 60 degrees and you want to bring it to 80. Well, one of the things you have to look at is how much time you want to do that in. The industry standard has been 1 degree per hour. So you have a 20 degree temperature differential, which is a delta T, the temperature differential between where you are and where you want to go. So most pool heating manufacturers and suppliers will go with the 1 degree per hour. So at 1 degree per hour, you're going to need, because you know you need 833,000 BTUs to raise it 1 degree. So let's round it to 800,000 BTUs. For simplicity, you're going to need an 80% heater that is at 1 million BTUs of energy because of the loss you get inside of the heater itself. So you need a tremendous amount of BTUs to raise that temperature. Do you really need to raise that temperature in 20 hours? If you're a commercial facility and you're closing down your pool to do work or you're opening up for the season, you're not opening the pool 20 hours before you want people to go into it. So if you do it in 40 hours, now you required half the amount of BTUs because there's a big difference between the BTUs it takes to raise that temperature and the BTUs it takes to maintain that temperature. So now I'm going to talk about really the real world savings where it comes into when you go to higher efficiency. So back to that 100,000 gallon pool where we're going to heat it 1 degree per hour. So we know from the last items we talked about that we need 800,000 BTUs to go into that pool to raise it from 60 to 80 degrees in 20 hours. So with an 80% unit, it would take 20 million BTUs to heat that pool up in that amount of time. If you went to 95% efficiency, picking up 15% of efficiency with condensing systems and high efficiency systems, it would only take 17 million BTUs, which doesn't sound like a whole lot, but it's a single heat up cycle we're talking about, a very small time of your pool, not the larger picture. So if we convert that to propane, which a lot of customers around by us use, for an 80% standard pool heater, it would take 222 gallons of propane to heat that up from 60 degrees to 80 degrees in 20 hours. Go into 95% efficiency, it would only be 188 gallons of propane. So it's not a significant savings, but it's about 15%. The regional price for propane in our area is about $1.25 a gallon. is the going rate for the 2019 season that we have seen. So if you take it at an 80% system at 222 gallons, that's $277. You go to a high efficiency system, that's a condensing based system, at $1.25 at 188 gallons, it's $255, which still comes out to 15%. Again, it's not a tremendous amount of money. But if you look at a 100-day season, that your pool is open from Memorial Day to Labor Day in the Northeast, you're getting a minimum, this is again a minimum amount of runtime on that heater is about 1,500 hours. Okay, most are running more, but let's take a baseline of 1,500 hours. So at an 80% system, putting in 1.5 billion BTUs for 1,500 hours of runtime would be 16,666 gallons. So if you multiply that out by 125 a gallon, you're coming up with roughly $20,000. You go to a 95% system, it is 1.275 billion BTUs and 14,166 gallons, which would come out to $17,500. So you're having a savings of about $2,500 a year on the low side that you're saving in propane, not including the environmental savings of the amount of carbon footprint you put out, greenhouse gases, and the system is not running as hard. So again, your parasitic costs, maintenance, and different parasitic costs like that. Let's take the scenario out of an outdoor pool and let's bring it to an indoor pool that runs 365 days a year and wants to maintain temperature. So you have that same 100,000 gallon pool with a 2,500 square foot area. So at 2,500 square foot of surface area, the air temperature in the room is 72 degrees. The water temperature wants to be maintained at 85 degrees. You only require 390,000 BTUs to maintain it. So if we look back at how we had it with a 1 degree an hour, where we needed to put 1 million BTUs in to raise that temperature, but to maintain it, we only need half that amount of BTUs to maintain it. So now, unless your heater is a modulating or a more intelligent unit, you're short cycling and you're putting all this heat in there all the time. Patriot Pool Heating Company has not come up with anything revolutionary or Patriot Pool Heating Company did not come up with anything revolutionary. We just took the knowledge that we have and out of the box thinking and looking at the math behind all of this and came up with a semi-custom engineered system. Patriot Water Heater has come up. Patriot Pool Heating has come up with a better mousetrap. We have taken the math and the physics and understood it and boiled it down to come up with a better system. Our system is a semi-custom, custom engineered system to fit your environment. Especially with indoor pools and water parks and stuff like that, we have multiple bodies of water at different temperatures. So we talked about all the math behind it with BTUs and all that fun stuff like that. So we talked about the maintenance requires a lot less BTUs to heat the pool, a lot less energy than it does to bring the temperature up. So you have a heater that's running at a high input, but doesn't require it all the time. And then if that heater goes down, now that whole body of water is closed. So what we've come up is from our knowledge being an HVAC and having that experience with condensing boilers and being a hydronic contractor, the light bulb went on. And we said, there's a better way to do this. There's a better mousetrap to be built. So we took off the shelf condensing boilers that modulate, which means they go up and down like the accelerator pedal in your car based on the temperature and the demands of the pool, so it can run at full or back down. So we came up with this condensing system that we have put on a rack that we engineer for what is needed. And what we mean by semi-custom is we use best-in-breed parts to put this all together. We rack it all up like this and fit it in a particular space that is available in your mechanical room. Besides heating the pool off of this, if you have lockers and showers and domestic water needs, we could also heat your domestic water off of this system. and we have redundancy. So say you have 3 heaters for 3 bodies of water out there, and they're each 250,000 BTUs each. One of them go down, that body of water is closed. With this system where we bring it all back and use multiple boilers here, if one of them goes down, all the bodies of waters are still being heated. And we can get this taken care of and get this repaired. Plus it is indirect heating. So we do not bring any of the corrosive pool water into the heat exchangers. Everything is separated by titanium heat exchangers that are out by the pool. It allows us to run lower water temperatures from the boilers, again, increased efficiency. And it is modular and it is up off the floor. As you know, in pool pump rooms, there's always water on the floor. Well, we keep them up high and the serviceability to them. So we go with US boiler K2s, which we found tremendous success with. They are a local Lancaster company. These units are all assembled in Lancaster County, and we fully believe in dealing with local business. The support we get from them is second to none. So it is a condensing boiler that is in here that would be used in any commercial or large residential project. So the other advantage to this is that a standard HVAC technician that is familiar with boilers, because there's hundreds of thousands of these installed and the parts are readily available. With most pool systems, the parts are proprietary to that particular heater. So it has a small mass, high efficiency heat exchanger, which we don't run pool water through, and they have a 10-year heat exchanger warranty, which is the longest in the industry compared to a pool heater. I would just like to thank you for taking time out of your busy schedule for watching the video about what we do. The next video is going to be really, really exciting about how we custom design and engineer systems for the specific application. If you have any questions, we are a full design, consult, and installation firm. Please leave a comment below. Reach out to us via our website. We would love to talk to you and love to hear anything you have to say. Thank you for watching and have a great day.